Hello and welcome back to the video lecture series on statistics for machine learning. Already we have gone through, we have started with the basic concepts of probability and we have talked about random experiments, outcomes and events. Just one quick thing, sometimes events and outcomes may sound to be very synonymous, but just to understand the difference between outcomes and events clearly. So outcome is the result of an random experiment. So when I throw a die, I get a head or I get a tail. So that is my outcome. Whereas event means combination of multiple outcomes. Okay, it might be a single outcome or multiple outcomes, right? Say for example, when I'm tossing a coin, I'm going to get the outcome as head or a tail. When I toss a single coin. Now, that outcome head or that outcome tail can be my event also. So that's going to be an elementary event, right? When I define the event as head or define the event as tail. Now, when I throw two coins, right, parallelly, so both the coins may have outcomes either head or a tail. Now I can define an event as both heads. That means both the coins have resulted, both the coin tosses have resulted in heads, right? So that is a HH, that kind of an uh, outcome. H as well as second one also gives an H, right? So in this case, again, this outcome is an elementary, this event is an elementary event because only one outcome is there in as a part of this event. But when I say another event as one head, one tail, so in that case, I can have both possibilities, either a HT, so the first coin gives a head and the second coin gives the tail, or a TH. So the first coin gives a tail and the second coin gives a head, right? So in that case, it's not a one single outcome, it can be two outcomes, right? So that's the subtle difference between events and outcomes, right? Same way, when I throw a dice, right, I can and define an event as even points. So that case, what will be the thing? So the outcomes which might be there are sorry, even point means two, sorry, two, 4 or 6. And when I say odd points, it can be 1, 3 or 5, right? So this point needs to be very clearly understood. Now comes the next very important concept, and these concepts are all like foundations of the theory of probability. So events, they can be called as mutually exclusive events. So say I have two events, E1 and E2. Okay. Now, when can they be called as mutually exclusive events? When the outcomes are not common. Any one of the outcome are not common, right? So say for example, when I define an event as head and I define an event as tail, right? These can never be overlapping, right? These are elementary events and these are having different outcomes as the part, right? So that is mutually exclusive. Means when one event occurs, automatically it means that the other event will not occur. Or say for example, when I say these two events, say even points as E1, okay, and the odd points as E2, say for example. In this case also, I can say that these two events E1 and E2 can never occur together. When I throw a dice and if the outcome is 2, that means event 1 has occurred. Obviously, at that time, event 2 cannot be the possibility, right? So these are mutually exclusive events. This is something we need to understand very clearly. When there is no overlapping or common element, right? In the same way, there is other very important term which is called ex exhaustive. That means if I combine these two events, okay, whether that can cover all possible outcomes. So for example, here when I have the event head as the E1 and I have tail as the E2, right? Obviously, E1 and E2 I mean, if I combine them together, right, that's going to be the full set of outcomes. There cannot be any other outcome beyond these two. Same here, when I combine E1 and E2, where E1 basically means even points and E2 means odd points, when I combine them, that covers all possible outcomes. So that is called exhaustive. Those two events are called exhaustive events. The third very important term, I mean, just in line with this, is equally likely. Okay, what do we mean by equally likely? So, say for example, again, when I talk about the throwing of a die, tossing of a coin, and the events E1 as head and the E2 as tail. Now, when the coin is perfectly unbiased, when I throw, obviously the outcomes head and tail are absolutely having the same chance of occurrence, right? So these two events, E1 and E2, are called equally likely events. Okay, I mean, I cannot give a preference to E1 than E2, or I cannot give a preference to E2 than E1. Same way, when I have I mean, two coins being tossed together, right? So each of, I mean, and if I create an event for each of the different outcomes, an elementary event, again, it's equally likely. I mean, all the four possible events, they are equally likely, right? I cannot give a preference to one ahead of the other, right? So this is another very important term, equally likely. Okay. The next thing that we need to understand is cases favorable. So cases favorable to an event. Okay, favorable to an event. So what are the cases favorable to an event? So for example, when we consider the rolling of a die, and we consider the event, say even points. Okay, this is the event. So E1. Now, what are the cases favorable to that event E1? So when I have the outcome as 2, or the outcome as 4, or the outcome as 6, I can say that the event E1 has occurred, right? So these are the cases, these outcomes 2, 4, and 6 are the cases which are favorable to the event E1. Same way, outcomes 1, 3, and 5 are the cases which are favorable to the event E2. Okay, and this is a very important concept when we define probability. Now let's come to the definition. This is called the definition of probability. So let's consider for that a particular experiment has n possible outcomes. So there are n possible outcomes in a particular experiment, random experiment. Okay, out of that, impossible outcomes, and there is a qualifier. So the outcomes should be, or the here should be, outcomes should be mutually exclusive. Okay, that's one thing. Okay, then it has to be exhaustive. Okay, that's the second thing, and equally likely. So equally likely, and we have already discussed what each of them mean, right? So mutually exclusive, exhaustive, and equally likely. Then in that case, when we have in favorable cases to that particular event, right? When we have in probable favorable cases of the event, we say that the probability of having that event, probability of having the event, so probability is equal to the number of outcomes favorable to the event, so that is m, and the total number of possible outcomes, so that is n, right? So first is number of outcomes which are favorable to that particular event. So when we are considering that event to be E1, say for example, okay, E1, so a number of favorable outcomes to that event E1 divided by the total number of events. Okay, now let's put the things into perspective. let's consider the random experiment as the throwing of a die. Okay, fine. So throwing of a die, that's the random experiment that I am conducting. And what is the event? Say, for example, the event is uh, the odd points. Okay, odd points being coming out in the surface. So what is the probability? So that was a E2, right? I mean, when we defined in the earlier thing, when we defined it, it was the E2, right? This was the E2, right? This odd. Now, when I do this, so what is the number of outcomes which are favorable? Obviously 1, 3 and 5. So total M is 3. Okay, 3 possible outcomes which are favorable to the event E2. Okay, and those are 1, 3 and 5, right? And what is the total number of possible mutually exclusive, exhaustive and equally likely outcomes? So that is 6, either 1 or 2 or 3 or 4 or 5 or 6, right? Now this is the probability of the event E2, which is basically what? The odd points. Okay, so what is the probability value? If I just do a simple math, half. Now say for example I define another random event, I mean another ad hoc event. Say for example the points being the sum of points, point sum sum is equal to say 5, if that is what I define as my event E3. So now let's try to see what will be the probability. Okay, so probability of E3, what is going to be the case? So when can I have as 5 point sum? Oh, when I'm rolling 2 dice. Okay, this is when I'm rolling 2 dice. Roll 2 dice uh, together, 2 dice together rather. Okay, so either it can be both ones, or it can be 1 and a 2, or it can be 1 and a 3, right? So like this it can go on, and like this we carry on till it can be 4 and a 6, it can be 5 and a 6, it can be 6 and a 6. Okay, so when I'm rolling 2 dice together, so the point distributions can be like this. So either both of them have a 1, or both of them have a 2, or both of them have a 3, or first one has a 1 and second one has a 2, like this. We can have like this, right? So in what cases it will be 5? So either 1 plus 5, sorry, 1 plus 4 is a 5. So 1, 4, when I get the occurrence, I will have a 5. Or I can have a 4, 1. Okay, 4 plus 1. Okay. I can have also a 2, 3. Okay. Or a 3, 2. Okay. Anything else? So 1, 4, 2, 3, 3, 2, 4, 1. Only in these 4 cases I can have a sum total of 5, right? Now, so there are 4 favorable outcomes to that event E3. And what are the possible outcomes? Possible outcomes are 6. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Same way, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Right? So like this, you can have 36 different options, right? So 6 square basically. So for each of them, you can have 6 options. 6 into 6, 36. So 36 is the total number of possible outcomes, which are mutually exclusive, exhaustive, and equally likely. So what is the probability now? It is coming as 1/9. The probability of the event E3, which is basically point sum as 5. Okay, so I hope you understand how we can calculate the probability of random experiments. So when we come back, we will cover some more such examples of how probability is being calculated from the simple definition that we have talked about. Okay, so stay tuned.